Hey everyone, hope you're doing well. So today we're going to be looking at resizing elements in our drawing application. So let's just get right into it. If you haven't seen the first two parts, I'd recommend going and checking them out. That will take you up to where we are now in terms of the code base. Otherwise, I'll leave a link to the GitHub repository below and you can kind of catch up from there. So what we have up to now is we can draw rectangles, we can draw lines, and we can select this selection tool and move our elements, and we have this cursor change when we hover over. So now we're going to focus on the resizing basically. And just before we get into that, we're going to do a slight refactor, and this refactor comes because of this bit of code here. So when we're in this case moving, and when we're going to be resizing in the future, we need to calculate which coordinates are in which kind of area of the rectangle. So what I mean by that is, if we draw the rectangle from top left to bottom right, we know that x1 and y1 are in the top left, right? And x2 and y2 are in the bottom right. But if we draw the rectangle, this way, from bottom right to top left, then wherever we drop the mouse, it's going to be x2, y2, and x1, y1 is in the bottom right. So we can't kind of deterministically say where these coordinates are going to be, right? It all depends on the direction we draw it, for the rectangle, for the line, same thing. So what that means is around the code base, we're going to have kind of a few of these kicking about where we need to calculate the minimum and the maximum in terms of trying to see if the mouse position is inside. And when it comes to resizing, we need to do the same thing. If we're at the top left corner and we want to resize the top left point, we need to figure out which coordinate we're at. So what we're going to do is a very quick refactor, which just basically says, okay, when I'm drawing a rectangle, regardless of how I draw it, as soon as I finish drawing it, as soon as I do the mouse up, just do one final update and to make sure top left is x1, y1, bottom right is x2, y2. So that just makes it consistent with every other rectangle, and same with the line. So the line, we're going to say if it's not vertical, so any position, if it's not vertical, then make the left hand side x1, y1, the right hand side x2, y2. And if it is vertical, we'll make the top here as x1, y1, and the bottom as x2, y2. So it just gives us kind of a consistency throughout all our shapes, and it just makes it really easy for us to move things. So let's just go ahead and do that. So I'm going to copy this piece of code here. I'm going to go down to the handle mouse up. This is where we want to do this. And we're going to say if, so this, in this case, it's if we're drawing, right? So we're going to say if we're drawing, when we have the mouse up, what we want to do is we want to adjust, let's say adjust element coordinates. So we're going to create a function that's going to adjust them, and that function is going to return to us the new coordinates that we want to use, right? So I'm going to do x1, y1, x2, y2. And then once we have those coordinates, we can just, the same as usual, we use this method, update element, to update the element in question. So we're going to need some sort of ID or index, x1, y1, x2, y2. And what I'm going to do is I'm just going to copy this, so I don't have to retype it. There we go. And then we need the type. And because we're drawing, similar to when we were drawing the element before, we know that's the last element in the array, so we can just kind of copy that. And from the element, we just need the ID and the type here. We can pass in this entire element inside this method here, and then we can go ahead and create this method. So let's pop that global, and let's make this an arrow function. Cool. So we're adjusting the elements for this coordinate. So this is all based on the type, right? So we're going to destructure type, and we will take the x and y coordinates from the element. And what we essentially want to do is, based on the type, we want to check the coordinates and return back the adjusted ones, right? So let's do for rectangle, and this is going to be type is equal to rectangle, then we're going to find the min and max, and that's what we copied from earlier on. And then we're just going to return x1, y1, x2, y2, but we're going to update the values here, right? So x1 is going to be min x, y1 is going to be min y, x2 is going to be max x, and y2 is going to be max y. Cool. And if it's not a rectangle, in our case, we know it's going to be a line, so we just need to do something very similar. In our case, we're going to say, we said if x1 is less than x2, then we're going to keep it the same. And also we said if it's vertical, so x1 is less than x2, and if it's vertical, which is x1 is equal to x2, put that in the brackets, so if it's x1 is equal to x2, that means it's vertical, then we're going to check the y coordinates. So we want to make sure y1 is less than y2. So that's just the logic that we kind of talked about earlier on. If that's the case, then we just want to return x and y coordinates as they are, because they're already in the right place. If those conditions are not met, then what we want to do is we want to swap the x and y coordinates around, right? So we want to swap the start and the end points. And this is going to look a bit weird. Hopefully it's not too confusing, but we're essentially going to say x1 is going to be x2, y1 is going to return y2, and same for the x2 coordinates. Hopefully that makes sense. I think that's y1. Perfect. Cool. So that's all we have to do, and a quick test for that is we can just draw a rectangle starting from the bottom right to the top left, and a line from the bottom right to the top left. We can just jump into the state here and just make sure that the x1 and y1 are essentially the smaller numbers, which they are here. That's fine, and that's fine. So yeah, cool. So let's get on to actually resizing the elements. So what we had before is this get element at position function. And this is called on mouse down and on mouse move. So this is where we do the hover. So we're going to update the hover effect first, and that should make it a bit easier to go through. So we're going to go into this get element at position method. And what this did was it goes through all the elements, it finds out if the mouse position is within the element, then it just returns the existing element. But we need a bit more information, so we don't need just, hey, are we inside the element? We also need, all right, which point are we near within the element? So instead of just returning kind of true false, we want to return information about where we are. Are we on the top left? Are we the top right? Are we just generally inside? And same for the line, etc. So what I'm going to do is I'm going to refactor this method. Instead of is within element, I'm going to refactor it. I'm going to rename it to position within element, and instead of returning a boolean, which it does now, it's actually going to return, we're just going to update it to return a string, right? It's a bit hacky, but the string is going to contain information of the position basically. So if we just update it as is, right now it would return, for example, inside, because in this case true means it's inside the element. Otherwise it's going to return null, right? And we can just say null basically just means it's not found, right? So that's the kind of the false scenario here. So let's copy that for the rectangle and for the line. So, and in fact, because we did our earlier refactor, we can remove this and we can change this to x1, x2, y1, y2. There we go. So now we know that it's inside, that's fine, but we also want to have the cases for all the in the rectangle, all the corners. You could do the sides as well. I'm just going to stick the corners, and for the line, just basically the start and end point. So I'm just going to name a variable top left, and what we can do is we can create a function which checks if an x and y coordinate is near another x and y coordinate. So we have the mouse x and y up here, right? So we're going to take that x, y, and because this is the top left, we know that we want to be checking it against x1 and y1, right? And this is the thing that makes it a bit easier for us refactor. And if it is, in this case, we want to return a string. So I'm going to pass in the string that we want to return, which is TL, top left. Otherwise, it's going to return null. So yeah, let's do that. And let's create this function in the global scope. And this will be x, y, x1, y. That's fine. Cool. So I've just copied this function in, and it's slightly broken this. There we go. I just copied this function in, and what we're essentially doing is we're taking the x, so the mouse position, we're subtracting the x1, and we're basically checking if they're near each other, right? So initially I would have done x minus x1 is 0, but similar to the line, we need a bit of an offset, right? So we're basically saying, all right, x minus x1 is less than 5, and of course it could be negative or positive, so we're doing this absolute. And we're doing exactly the same for the y. So we're saying if either of them, or if both of them rather, are within 5 of the point, then return the name that we provided, otherwise return null. And the final thing we can do here is we can essentially pop this into a variable and just say, hey, just return whichever one you find, right? So if you find top left, return it. If it's null, then return inside, so on and so forth, right? So that's generally the kind of the pattern we're going to do here. So I'm just going to copy and paste in all the other corners. So there we go, top left, top right, bottom left, bottom right, inside, and I'm going to do exactly the same thing for the line. right? So I'm just going to copy this in, and the line is exactly the same. So we define, in this case, 2, which is start and end, as well as inside, and it's going to be the start is going to be near point x1, y1, because that's the way we set up the line. Again, it's deterministic. x2, y2 is the end, and we just return whichever one is available. So now we need to go down to this get element at position, right, which currently just returns the element, and we actually need to also return the position within the element. So what we're going to do is we're going to sort of hack this in with the return. So I'm going to change this, instead of a find, I'm going to change this to a map, right? So this is going to go through all the elements, not the most efficient way, but that's fine. It's going to go through all the elements, and it's going to basically return if, it's just going to return the element. So we destructure the element, and then it's going to add a field called position. So it's going to check the position within an element. In this case, it's either going to return one of these strings or it's going to return null, depending on the element type. And we can pop this into a new line. And down here, we can then basically find the first one that's not null, right? So some of these are going to return null, but we want to find the first one that's not null. So if it's on a position, we want to see, we want to return that. So we can do that by just saying find element, and element dot position is not equal to null. Cool. So now get element position returns this element, and it's got the position inside of it. So let's have a look at where this was used. Yeah, we can do the mouse move first. So we're going to extract this out into an element constant, and now we just replace that. So it's exactly the same as before. But now what we have access to is the position within the element. So if the element exists, we're not just going to return move, because now it could be, you know, one of the few things. We're actually going to return a cursor for the position that's within this element. So that's going to be a function, and I'll pop in element.position, right? So we're going to create this function here as well. Go back up to global, and there we go. I'm just going to copy this function in again to save the typing, but I'll explain what it's doing. So this one is a very simple switch statement. So taking in the position, and then based off of the string of the position, it's just going to return a string, which is the cursor name. So for top left, bottom right, and then start and end. So I've just, for the line, I'm just going to use the same cursor. It's going to be a north, west, south, east resize handle. And then we've got another case for top right, bottom left. And then anything else, in this case, it's just inside, it's going to be move. So we're going to do that. And yeah, let's see. I think that should be everything in terms of the hover. So let's see if that works. So we're going to draw a rectangle. We're going to draw a line. We're going to take the selection. So I've still got the move, which is fine. And if I go up to the top, there we go. Bottom, yeah, and all four corners. Yeah, that's looking fine. So yeah, that's in terms of the kind of hover. So now we need to handle the actual resize. Now, if we click on now, it's still going to do the move because it still thinks we're moving, right? So the first thing we need to do is we need to differentiate resizing from moving, and then do the resize. So if we go up to our handle mouse down function, yeah, so we've got our element here, and what we can do, you can see here that if there's an element, then we're just setting it to moving, but that's not what we want. We want to say, hey, if element position is inside, then yeah, okay, we're moving. That's what we had before. Else, we're going to do, so yeah, else we're going to do resize. And that's all we need to do here, right? So all this is done is basically said, hey, if we're moving, fine, continue as normal. But if it's not inside, so right now it would be returning top left, then don't do anything. So you can see here, I'm clicking, it's not doing anything. So what we need to do is on click, on the handle mouse move, we need to add in one final if statement. So this is here, and this is while we're clicking and we're moving around, but we're going to have another one for resizing, right? And resizing is going to be pretty similar to moving, right? So we want to take the selected element, so that's the existing element. So in this case, it'll be the rectangle there. And what we're going to do is we want to adjust just the point or just the coordinate that we're moving, and that all depends on the position, right? So what we need to do here, or what we can do, is we can add a function which is basically going to bring us back. We can give it the coordinates or the existing coordinates and the position, and it will give us back the updated coordinates for that position. So hopefully that's a bit confusing. We'll look into it, and hopefully it'll make a bit more sense as we type it out. Let's destructure it from a function called, let's call this resized coordinates, right? And what we're going to pass in here is, so we need to pass in the mouse position. We're going to say, hey, here's my mouse X and Y. We know we need to pass in the position, which is, either going to be inside, top left, top right, etc. In fact, it can't be inside, it has to be one of the other ones. And then we need to pass in the existing coordinates, right? So I'm just going to do coordinates. Cool. And what we can do is we can remove this here. We don't need the offsets, so we can just take ID type, and then we can just destructure coordinates. I think I've called it here. Perfect. Coordinates. And actually, we do need to take the position, which now exists in the selected element as well. And it exists there just because, yeah, it's part of the element from the previous refactor that we did. So now we've got this resized coordinates. We're just going to assume that's going to bring us back x and y coordinates, x1, y2, and we can just like before, we can do this update element function, which updates everything here. So I think that's all fine. x1, y1, x2, y2. Cool, that's perfect. And now we can just create this function and see what that looks like. So let's go up here. X, y, positions, coordinates, that's fine. So now the coordinates that we want to turn are going to be based off of the position, right? So this is going to be similar to what we had previously. It's going to be a switch statement, and switch statement is going to be all based off of the coordinates. So let me quickly destructure the x and y. There we go, from coordinates. And what we can say here is switch. So based on the position, if the position is top left, right, then we know we want to return all the coordinates, but we want to move the x1 and y1. So what we can do here is return, we know x2 and y2 are going to stay the same, and x1, actually, let's update that to be the mouse's position, and y1, let's update that to be the mouse's position. So that's generally what we're doing here. So x2 and y2 are staying the same, x1 and y1 are going to change. And I'm just going to copy and paste the other cases, because I will definitely make a mistake if I tried to do this while recording. So there we go. There we go. So yeah, and you can see here that I've done start as well, because start is also moving x1, y1, the top right, bottom left, and then bottom right and end. And in this case, default shouldn't really ever get here. We could have actually included inside, the inside function here, so we could have done the move and the resize together, but I thought it might make a bit more clear if we separate them out, so it shouldn't really ever get there. And I think that should be it. So let's test this out and see if we've missed anything. So let's draw a rectangle, let's draw a line, and use the selection tool. So if I go up to, yeah, we can still move them fine, and resize. Cool, so that's not working, so let's see what we've missed out. Ah, cool, so I've accidentally called this resize instead of resizing. So let me rename that to resizing and try again. So moving is fine, and yeah, so we can see that resizing there is absolutely fine, and same with the square. Now, I know that there is one last thing that we've not considered, which is if we take this rectangle and we flip it around, and now we try and move it, it's broken. And that's because of the very first thing we did, which is handle mouse up redraws the coordinates when we are drawing, but it doesn't do it when we're resizing. So that means now when I've resized it there, x1 and y1 have moved up to the top right, and therefore kind of everything is out the window. So let's just update that to also include resizing. So we can just do drawing or resizing. And of course, when we're resizing, it's not always going to be the last element, right? So we're going to update this to be selected element.id instead of the last element array, which obviously breaks kind of drawing. So what we can do for a quick fix is up here when we mouse down, if we're creating an element, as well as what we had before, we can also just set this selected element to the element that we're creating, right? So we could do a bit of a refactor here and basically no longer use that element's length -1 everywhere, but I think it's fine. We can just take the ID from there. So now I should be able to draw the line in the rectangle, should be able to just resize these, move them, that's fine. And same with this, this, resize it. Cool. Yeah, I think that's everything everything we wanted to do. So thank you very much for watching. I hope you enjoyed it. Obviously we've hacked in a few things, but I think that's okay. So have a good day, and I'll see you in the next one.